So from vast data centres to mobile phones, the power of computers continues to transform our lives. But there are some problems across artificial intelligence, in the design of new materials, pharmaceuticals and clean energy devices that they will simply never solve. So even if we turned our entire planet into a giant supercomputer, we wouldn't be able to solve these and many other important problems. The good news is that if we could build a computing device based on fundamental quantum principles, we could. And so back when I was a long-haired undergraduate student, I lent this magazine to everyone in my quantum mechanics class. And the idea that we could build an unimaginably powerful computer by harnessing the bizarre laws of quantum physics seemed crazy. And I never got the magazine back, but I no longer think it's crazy. And so in 2001, I was really amazed to tackle this problem of how we get from the few components that we have in the lab to the millions that we need to build a useful quantum computer. And back then, in 2001, I was inspired by a really breakthrough proposal which showed that actually we can quantum compute with light. What we've come to today is the ability to manufacture a quantum computer based on light using the semiconductor industry as we know it today. So these silicon wafers contain millions of computer chips, and each of those chips contains billions of computers. And so back to the beginning of the story, the idea of using light is a very appealing one. Although it's flying around at the speed of light, these systems exhibit almost no noise, so they are not plagued by the noise that almost all other quantum systems are subject to. And so I switched from a matter-based approach to quantum computing and spent the next 2 years aligning and designing and assembling this forest of optical elements on a huge laboratory table. And this system implemented the key building block, a logic gate. Now, an impressive proof of principle? Sure. Manufacturable by the millions? Absolutely not. And that simply wasn't good enough for us. And so by 2008, we'd taken that entire laboratory bench full of optical components and put it onto a silicon chip measured in centimetres. Now that was really exciting progress and bode well for the future of quantum computing, but there was still plenty more work to be done. And so just 2 years ago, we were able to take those same building blocks and make them 1 million times smaller. But even more importantly, we used the standard tools of a manufacturing line of a big chip maker. And so this brought the prospect of large-scale quantum computing into sharp focus. And so we've spent the 2 years since developing and refining this blueprint, which people are starting to get very excited about. Now, I'm sure it won't be obvious in a quick glance, but all of the components are standard and no exotic fabrication or operating conditions are required. And this blueprint will enable us to build the first quantum machine capable of tackling important problems across artificial intelligence, genomics and genetic engineering, in finance, and in the design of new materials, pharmaceuticals and clean energy devices. It's also true that if you look anywhere across science and technology, you will find problems that a quantum computer can solve. And solving these problems will enable us to tackle some of the great challenges that we face today in climate change, in economics, in big data, in cybersecurity, and so the list goes on. And so to conclude, without a realistic plan of how to manufacture the millions of components that we need for a quantum computer, schemes are worth nothing. The only way that humankind currently knows how to make systems with that many components is using silicon chip manufacturing technology. And we're in the process of doing that to bring it to bear on some of these grand challenges. And I think just as the computer is now at the centre of our lives, so too a quantum computer will ignite a new technology revolution that will transform almost every aspect of our lives, society and economy. We'll build this device by the end of this decade, and so I'd like to finish by asking you, how would you like to harness it to improve your life and your business, and most importantly, how can we help you do that? Thank you.